leave a comment and also subscribe to share this video to your friends so that they can be able also to benefit. So let's dive in so that we can be able to get started on how you are supposed to answer this question. And we need to see now what was the main question that was asked. What were the questions that you are supposed to focus on? The first question that we said here is the question to do with motion graphs. And something that you need to be very careful with is understanding different features which is represented by motion graphs. For instance, if we are talking about distance time graphs, it means that the gradient of a distance time graph is going to give you velocity. But a graph like this one that we have here, which is a distance time graph, this graph is a speed time graph, which means the gradient of a speed time graph will enable you to get the acceleration of the object. And also you need to understand that another feature on a speed time graph that represents distance is the area under the graph. So I've seen questions like that, and at the same time you need to understand how you can be able to describe different motion graphs. Now, looking at this question here, we are told that a ship sails in a straight line between two ports, and then we are supposed to determine the maximum acceleration during the 100 minutes of the ship journey, right? So if you look at the gradient of each of the line, you see if I draw a tangent at this point, we're going to have a slanting line. As this line, if the line is steep, it means a high gradient. If the line is not very much steep, it means a low gradient, which also communicates less acceleration. So acceleration at this point is going to be less than this, and acceleration is highest where we have this particular section. That's where we have a very steep gradient. So what I did, I obtained the gradient of this section, and rise is 5 and the run is 12. But you have to remember that time was given in what? In minutes. And the speed was given in what? In seconds. So whenever you're going to work out the acceleration for the run here, I have to convert the 12 minutes to seconds by multiply by 60. And when I worked out, I got my acceleration translating to 6.9 times 10 raised to the power -3 meters per second square. And we were supposed to calculate the total distance. And I mentioned that from a velocity time graph or this speed time graph, if you work out the area under the graph, it means that is particularly the area under the graph represents the distance covered. So don't use the formula that distance is speed times time in this part. If you are given a graph, remember area under that section is represented by the area under that section represents the distance covered. So if we are talking about 42, remember we are told to consider 42 seconds all the way to 100 seconds. So which means we are going to work out the area of this section here. I subdivided it so that I work out the area of this trapezium, and then I work out the area of this rectangle in this particular section, so that I add the two areas together. Plus, now we work out the area of these rectangles, the rectangle that we have here. So that's going to be 60 to 100, that is actually 40. And then the height is 15, so that is going to be translating to what? So 40 times 60 times 60. This is going to be 2400 times 15. So if we work it out, I have to eliminate this one from here. So if I work out the total distance traveled, this is going to be 0.5 times 1080 into brackets 8.5 plus 15. So the bracket then plus bracket 200 times 15, and the total answer becomes 48,690. So the total distance becomes 48,690 meters. So, and in the event you are asked to convert meters to kilometers, you need to divide by 1,000, and that becomes 48.69 kilometers, which is the same as 48.69 kilometers. So this question did not really specify in which unit you are to give, so you can decide and give it as 48.69 kilometers, right? So the take from this particular tutorial is that ensure when you are working out acceleration from a speed time graph, you work out the gradient. And when you are working out distance covered by the object in a given section of a graph, you work out the area under the graph. Right. So we need to move to the next part, whereby we are supposed to calculate the resultant force that acted on the ship, whereby there is an acceleration of 0.0087, and we are given the mass. We are going to use the relation force is equal to mass times acceleration, and then if you apply that, you are going to get your answer 2 times 10 to the power 5 Newton. That's the force. That's according to Newton's second law of motion. That's when a force is applied on an object is going to accelerate. And if you take the mass of the object times the acceleration, you get the force that acted on that particular object. We're supposed to explain why the force of the ship due to the ship's engine is greater than the value calculated. So something that we need to realize that some of the forces exerted from the ship's engine is used to overcome air resistance and also water resistance as the ship is moving through the ocean. All right, so moving to question number 2, and in question number 2 we are talking about energy resources, and we are supposed to say the form of energy stored in water when electrical energy, hydroelectric power is being generated. And remember, most of the time what happens is that water is trapped in a dam on a raised area. Then that water is released so that it can be able to pass through the turbines, and it rotates the turbines so that it generates electricity. So the energy that is being used there is gravitational potential energy, which is converted to kinetic energy, and then it rotates the turbines, and then the turbines are able to rotate the shaft of the generator in order to produce electricity through electromagnetic induction. So we are going to look at the rate at which energy is transferred. Remember, the energy that we're talking about here is the energy gravitational potential energy. So, and gravitational potential energy is calculated by the formula energy equals to mgh. So, which means that we are going to substitute the value that we have into the formula so that we can be able to get that energy. But remember, the water is being released at 480 kilogram per second. So our rate is also going to be energy over time. Then if you work out the potential energy, you are going to get your answer here. Then our energy is 1.9 times 10 to the power 6 joules per second, remember. And then we are going to divide by time, which is 1 second. And then the rate becomes this. And something that we need to remember is that rate at which energy is transferred is basically power. So this is also referred to power. Now, the power scheme supplies a current. So this is the output power we can talk about in Roman 2, because we're given the current as 270 amperes and we're given the voltage as 600 volts. Yeah. So which means from electrical power, we know that power is equal to current times voltage. So which means that if we multiply 270 times 6,000, it means we're going to get 1.6 times 10 raised to the power 6 watts. And efficiency is given by the formula that power output is over total power input times 100. We get what? We get the efficiency. So if we plug in those values into that, we are going to get the power being translated to 84.2. Yeah, 84.2 percent. Yeah, and you are supposed to know in this topic advantages and disadvantages of hydropower schemes. The first thing that we need to realize here, the advantage is that they can produce enough energy and can meet the demand of the power that is required. They produce enough energy, of course, but the shortcoming is the initial capital that you need to start a power plant is really very high. And we can talk of the ecosystem being destroyed because for you to create for you to create that dam, you need to restructure the landscape. You need to destroy the habitat of wild animals. You need to displace people. So you need a large space. And also during dry seasons, you cannot have enough water to run this. So those are some of the disadvantages that we can talk about. Now, you need also to understand the difference between renewable and non-renewable energy resources. Those energy resources that you cannot deplete, you can never finish them, even however much you can be able to use them, they are called non-renewable energy resources. And those resources that you will be able to deplete, you cannot use them forever. They can be depleted. They are called non-renewable energy resources. So my question is, what are the examples of renewable and non-renewable energy resources that you know? So at this given point, we shall talk about renewable. Solar, will you ever use the energy of the sun and finish it? You can never deplete it. Will you ever finish the energy of wind, waves and tides? Geothermal, you will never deplete that. So those are some of the examples, but you need to revise more on that so that you, whenever a question is coming from there, you'll be in a position to answer that. So you need to understand also the concept of impulse and the concept of momentum and Newton's second and third law of motion. So first we need to appreciate the fact that impulse is the product of force and time. And impulse is equal to the change of what? The change of momentum, all right? All right, so in this case, we are supposed to calculate the resultant impulse on the balloon while it's accelerating. So we are having this balloon that is this given point, whereby the moment the air is going to be expelled from the balloon, this balloon is going to what? To move forward. Because as the air is being expelled from the balloon, there is a change in momentum. There is a force exerted on the balloon, and the balloon exerted force on the air as it's being excited. So the balloon is going to accelerate what? It's going to accelerate forward. Now, we are told as the air leaves the balloon, it experiences a force. The balloon accelerates from rest until it reaches a constant speed. It then travels from 0.67 meters in how many seconds? 0.18 seconds as this constant at this constant speed. Now we are supposed to calculate the resultant impulse. Now the first thing that we are going to do here is to use the formula V is equal to distance over time in order to get the speed, the constant speed attained by the balloon. Now once we have attained that, we are going now to go ahead and then use the formula impulse is equal to change in momentum. And we have our formula at this given point, whereby we're going to say change in momentum is equal to mass into bracket final velocity minus initial velocity. Remember, it was at rest, right? So if it was at rest, the initial velocity was 0. So which means that if we apply the formula, we're going to get 0.555 kilogram meter per second. That is the formula, the units for impulse. And also impulse can be given in Newton seconds. So you can give impulse units as kilogram meter per second, or you can be able to give them as 0.55 less. The law of conservation of momentum states that momentum before collision is equal to momentum after collision, provided there is no external force acting on the system. Now we are supposed to explain how momentum is conserved when this balloon accelerates. So as air is being expelled from the balloon, we know that it will accelerate forward because the speed, we were told that the speed is decreased, so it accelerated. And the air gain, so which means that as the air gain momentum in one direction, the balloon also gains equal momentum in the opposite direction. So you see momentum is a vector quantity, right? So if there's momentum acting in this direction and momentum acting in the other direction, then the two momentum will cancel out. So the balloon gets momentum in one direction and the air also gains momentum in the opposite direction but of equal magnitude. So we can be able to see that now momentum is the same, momentum is conserved in that particular case. Another concept that is key and important for you to remember is how to combine different forces that are acting on the body. And then what I did, basically, I moved this force in front here so that I could be able to work out the resultant force. And the resultant force, when we are having forces which are perpendicular, we're going to use Pythagoras theorem so that we can be able to say now the resultant force R is 0.4 squared plus 0.74 squared. Finding the square root of that, we are going to get our answer as 0.84 newtons. But since we are told to define to find the direction, and force, remember, is the vector quantity. Something that you need to remember is that vector quantities have both size and direction, and scalar quantities only have magnitude or size but no direction. So we are talking of a force. Force has both size and direction. So we need to find the direction relative to the horizontal. So if relative to the horizontal, then we are going to work out the angle that we are having here, which is going to be tan inverse of 0.74 over 0.4. That translates to 0.84 newtons as the magnitude, and the angle becomes 62 degrees. Moving to still talking about pressure, we shall talk about how pressure, our temperature affects pressure, and in this case, we are being told, explain in terms of particles how the air pressure inside the bottle changes as temperature increases. So something that you need to realize is that as temperature increases, the kinetic energy of the particles increases. So this results to a more frequent collision per unit area. So when the temperature increases, the kinetic energy of the particles increases, and this increases the frequency at which the air molecules or air particles is going to collide with the walls of this container, and this results to increase in pressure. So basically, this is the model answers you are supposed to write in your exam so that you can be able to earn all the formats. And if you have not subscribed to Proplan YouTube channel, consider subscribing so that in time I'm going to upload the second and third section of this tutorial will be notified. So let's move down. We're supposed to explain that we are told that the lid is removed from the bottle. State and explain how the air pressure changes. So if the lid is removed, it means that some of the air particles and molecules going to exit, is going to escape from the container. So we are going to have fewer particles inside the container. So there will be fewer collisions on the walls of the bottle. Then this is going to result to a decrease in pressure. The mass of water in the bottle is 0.18 kg, the specific capacity of water. Now you can see they are bringing the concept of thermophysics inside this. Quite interesting. So under thermophysics, we are learning about how to calculate thermal energy. And thermal energy equals mass times specific capacity times temperature change. So in this particular question, we're given the mass. In this particular question, we're given the specific heat capacity, which is given here, right? Interesting. And then we're given the temperature change, which is going to be our beautiful data at this given point. So this is the formula we're going to apply at this point. Now, once we have that, and you substitute between, we are going to get the answer being equivalent to 15,120 joules of thermal energy. Yes. As if that is not enough, they told that you never attended the class of pressure in fluids. And then they are going to ask pressure in liquids, which is going to be pressure in liquids is height times density times gravity, H log G. We are told another bottle is filled with the water to the top. And the bottle is 40 centimeters. 40 centimeters. You need to be very careful with that because they are not giving you the height in meters. So you have to convert it. Yeah. So if you forget that, you will start crying about the great boundaries. All right, so we are going to say it's 40 over 100 for us to convert the centimeters to meters, times the density, which is 1.0 times 10 to the power 3, times 9.8, which is gravity. And the gravity is just provided at the first page of your paper. And if you work it out, you're going to get 3920 pascals at the unit of pressure. All right, so moving down to question number 5, let's see the kind of question that was asked. Again, is a question from pressure, but it's a different concept, which means smelling from, the question is smelling like it's coming from pressure, but different questions are being approached there. And then the question said here, we have a balloon, yeah, which is inflated with air, so meaning we're having air particles which are dancing there, according to kinetic theory of matter. That states that air particles are in a continuous random motion. If we are talking about particles in this particular balloon, this particle will be moving in a random zigzag manner, colliding with the walls of the container. As temperature increases, the kinetic energy increases, the number of collisions increases. So as the air moves around, it collides with the walls of the balloon, and this results in the change in momentum. And when there is a change in momentum, according to Newton's second law, there is a force that is going to be exerted. And the force exerted per unit area is actually pressure. So in the event that you are told also that the volume of air in the balloon is 630 and the pressure in air is 1.0 times 10 to the power 5 pascals, and the balloon is tied to a heavy stone and then dropped into a lake, pulled down to the floor, then the pressure at that point is 1.4 times 10 to the power 5 pascals. We are supposed to calculate the volume of the air when the pressure is that. So we are going to use the formula pressure P1 times V1, pressure 1 times volume 1 is equal to pressure 2 times volume 2. So meaning that this is our V1, this is our P1 here, and then we are having P2 at this point. We are looking for what? Volume 2. Now substituting that, we are going to get our answer being equivalent to 450 centimeter cubic. We see then from here, as pressure increases, volume decreases. So which means that if we are talking about pressure and volume, pressure is inversely proportional to volume. Sometimes you will be told to sketch that graph, that as pressure increases, volume decreases. Explain why the volume of the air in the balloon decreases. We have already said that pressure is inversely proportional to what? Volume. So as pressure increases, volume is going to do what? Volume is going to decrease. So which means as temperature increases, the kinetic energy of the air molecules decreases. This decreases the number of solution volume. So that decreases the pressure. Hence, there is less force exerted on the balloon, so it will do what? It will compress. But the key fact here is that pressure is inversely proportional to volume. Okay. Yeah, so that is just added information and just putting on here. Let's look at the next question. And the next concept that I need to mention here is the concept of Hooke's law. You need to understand how to define Hooke's law. You need to know how to define Hooke's law. Hooke's law states that extension is directly proportional to the force applied, provided elastic limit is not exceeded. And the way you can be able to understand this also is that we have a limit of proportionality, yeah, at this particular point. The point where the graph stops being straight, that's called the limit of proportionality. Up to that point, extension is proportional to the force applied or the load, up to the last limit, the limit of proportionality rather. So if you are asked to define limit of proportionality, what are you going to say? If you are asked to define limit of proportionality, what are you going to say? Can you put it in the comment section there? What is the limit of proportionality? Just put it in the comment section. If you are preparing for this major exams, you should be knowing how to define limit of proportionality. From the graph, the limit of proportionality is the point where the straight line or the graph stops being straight. That point where I've indicated. And then you need to know how to state. So if you are asked to state limit of proportionality, you define it, we are going to say this is the point up the maximum point up to which extension is directly proportional to the load or to the force. Maximum point up to which extension is proportional to the load. Okay, all right. So if you have understood that, you need to understand also the concept of Hooke's law. Hooke's law formula is force is equal to the spring constant times extension. So if you're working out the spring constant, you need the force and extension. So where are you going to get the extension and the force from? You go to the section of the graph where you have a straight part, then you can read the extension being 100 millimeters, and you read the force down here, or the load, which is 14 Newton. If you work it out, you are going to get your answer 0.14 Newton per millimeter. Right. And then there is another question you can be asked. The original length of the spring was 120 millimeters. The original length was 120, meaning when when there's no load exerted on that spring, it's 120 millimeters. Then calculate the length of the spring when the load of 8.5 Newton is added on it. So what does that mean? What does that mean? When a load is added on this, it's going to stretch. It is going to be long. So which means we are going to go to our graph. So once we go to our graph, we are going to check where we have 8.5 Newtons, and then we read what is the extension when we have a load of 8.5. When I did that, I got it to be what? 60 millimeters. So for you to get the new length, it will be the original length plus the extension. Extension is by how much it has extended. So it has stretched, how much the length has increased. So which means that we are going to add 120 plus 60. We are going to get 180 millimeters. Now, another concept that you need to know at IGCSE level is how to calculate weight. Remember, weight is a force, so which is calculated by mass times gravitational field strength. So here, if we are told that the object was having a weight of 4.0 newtons, and the acceleration due to gravity of that particular planet is 8.7, then we have no option other than saying that mass is equal to weight divided by gravity, and that is going to give us 4.0 divided by 8.7, giving us what? 0.46. So weight is considered as a vector quantity because it has both sides and what? Direction. Yeah. And the difference between mass and weight is that mass is constant everywhere, but weight vary from one place to another because weights depend on gravity. Mass is a scalar quantity, weight is a vector quantity. So you need to know how to define different sections. So we are going to move to question number 7 in the next tutorial. If you have not subscribed to Prof Learn YouTube channel, consider subscribing so that when I'm going to do more of this section, you'll be notified. All the best. Good luck in making exams. Leave a comment down below if this video was helpful to you. See you in the next video.